Okay, I'm recording now. So here's problem number 21. Now we got a couple things going on here. One, we're going to note that there's two places that were improper. And then the other thing is that we got an absolute value sign there. So I'm going to try to take care of both of those problems at once. First of all, I'm going to note that this integral is equal to the integral from negative infinity to 0 of e to the negative absolute value of x dx plus the integral from 0 to infinity of e to the power of negative absolute value of x. Now, in this entire range, e is negative, so the rule for absolute value for that particular part, so the limit as a approaches negative infinity is going to be, this is from a to 0, and we're going to go e to the power of negative x dx. Again, I get to say negative x because all the values of x on this interval are negative. Plus the limit as b approaches infinity of the integral from 0 to b of e to the negative x. And in this case, I just get to strip off the absolute value signs because all the values of x are positive in this interval, dx. All right, so I've got the limit as a approaches negative infinity of the integral from a to 0 of e to the x dx plus the limit as b approaches infinity. And in this case, I know what that antiderivative is. It's negative e to the negative x is evaluated from 0 to b. This is the limit as a approaches negative infinity of e to the x is evaluated from a to 0. This is the limit as b approaches infinity of negative e to the negative b minus a minus e to the 0. This, by the way, as b gets large, e to the negative b is going to be also essentially a very small number. This is going to go to 0. This whole thing part here is going to be 1. And then over here, the limit as a approaches negative infinity of e to the 0th minus e to the a. Well, as a goes to negative infinity, this is going to go to 0. So we end up getting 1 plus 1, where the answer is 2.